I barely passed start. I'm so bad.
You choose to. Alright, so today we're learning the quotient rule. Again, remember that not every time that you have a quotient does the quotient rule have to be applied, but we're going to do a little review here. And for this particular problem, the way we found the derivative before in the past was to rewrite it in polynomial form. So let's go ahead and try to do that, see if you remember, and let's find the derivative of it. So what would I do to it first to rewrite it in a different form?
Move x squared to the top.
Bring the x squared up, and then it would become x to the what?
-2.
-2, and it will be multiplied with this, right? So let's do that. When I multiply with this, what do I do with the exponents? We add them. Are we finding the derivative already? No, we're just rewriting it, right, in a different form. Yes? It's not P, ma'am, it's an F, it's just that they're really close to each other. Okay? So, what would be f of x here? -2 and 3, that gives me what? 1, so that's 2x. We have 2 and -2, that cancels out, so it's just -3. And then 2 times x to the -2 is 2x to the -2. Everybody with me? Alright, so now it became something that's in polynomial form, which we can get the derivative quite quickly using the power rule, right?
Yeah.
So let's apply it and find the derivative. What's that going to be? 2. Derivative of 3? 0. Derivative of this? -4x to the -3. Okay, we don't like negative exponents, so send it down. So we get 2 minus 4 over x to the third. And I want it to be one single fraction. So what am I missing?
2x to the third.
We've got to multiply by x to the third, right? So we can get a common denominator. And x to the third, so we end up with 2x to the third minus 4. Pretty good. Could I have gone even further if I wanted to? Could I have factored some more? What could we have taken out of here?
2.
A 2 and then made it x to the third minus 2, right? If I wanted to. But is that going to help me cancel anything else out? No, so this is sufficient. This is good enough. Pretty cool? Alright, so, you remember those two really cool guys that I was talking about, Leibniz and Newton? And that together they pretty much invented everything that we know today as calculus, right? Well, just like Leibniz was the first to publish the proof of the product rule, Newton was the first to publish the proof of the quotient rule. So one of them thought, using multiplication, and the other one was really good working with the division, right? So Newton is given credit for the proof of the quotient rule, which is what we're going to learn. And we're going to apply it many times so we can practice it and understand it. Okay, so again, this is a rule that we use when we want the derivative of a quotient. The derivative of something divided by something else. Cool? Alright, so I'm going to write the rule first, and then I'm going to write a different version of it to help us remember it, okay? Ready? So, the rule is like this. The derivative, so start getting used to this notation, d dx. Okay, that means derivative. That's like f prime, that's like y prime. Okay, so that means find the derivative of some function f of x divided by some other function g of x. If I ask for the derivative of something like this is what the answer is going to be. You ready? It's the derivative of g, it's g of x times the derivative of f minus f of x times the derivative of g all over g of x squared. Seems complicated? Think you can memorize it?
It's kind of like the other one.
It's kind of like the other one?
First over G. That one.
Over g squared?
No.
And the other one had a what here? Plus? Oh man.
And it started.
And it started the other way, didn't it?
They started at the first.
Times the second. Wow. Okay, well let me show you an easier way to remember it. Yeah? Alright, so here's another way to remember it. So we have a function on the top and a function on the bottom, right? So what we're going to say is we're going to say the derivative of high over low. The derivative of the high function over the low function. And all you have to say is g of x is which one? Is it the high one or the low one?
Low.
So it'll be low, and then we're going to say the derivative of the top one, which is high. So low d high, you with me? Minus f, which was high, times the derivative of which one? The low over low squared. Does that seem a little easier to remember?
Not really. Low high.
Not really?
I think I will remember.
I'll remember this
FX
I mean,
one
if I keep saying it
better.
over.
If I say it
Sounds
over
like a
again.
What does
song.
the d high mean?
Low D.
Derivative of the high, d low,
Low.
derivative of the low. Okay, so let's say it together. Ready? We're gonna say it with some feeling. Okay, so we're gonna say
Motion.
low,
Low.
d high,
D high.
minus,
Minus.
high,
High.
d low,
D low.
over low squared.
Over low squared.
Woo! Go low horns.
Yeah.
Okay, let's try it again. Ready? What is it?
Low.
D high.
Minus. High. D low. Low squared.
Good job. Okay, you got it? All right, so we're
I
gonna
don't know, sir. I don't know if I
practice
felt it.
it. You felt it?
I don't. Yeah.
Awesome. We're gonna practice it, and hopefully by the end of today you'll have it memorized. This shouldn't be an issue. So what we're gonna do is we're gonna do the same exact problem we just did, but we're gonna do it with the quotient rule, because we can do it because it's something divided by something else. So let's try it, and then you'll decide which one was easier for that particular situation. Okay? So let's do it. We're gonna jump straight to the derivative. Okay, so that's what? What did we say? What do we start off with? Low, which is
X squared.
x squared times
D high.
d high. So what's the derivative of the top?
6x squared
6x squared
minus 6x.
minus 6x. So again, this is high, right? And this is low.
Oh, I just thought it was you.
Minus.
2x
Minus what?
high.
High, which is 2x to the third minus 3x squared plus 2 times
D low.
d low, which is
2x.
2x. All over
X to the 4th.
all over
Oh, yeah.
low squared. So x squared squared. That was the calculus part. The rest is algebra. Being able to manipulate it and simplify it. So let's see if we can do that and see if we can make this answer end up looking like this one. Ready? Alright, so let's do it. Distribute. X squared times 6x squared.
6x to the 4th.
X squared times negative 6x.
6x.
Okay, here we're going to distribute and then change its sign because of the minus. So 2x times 2x to the third. But then it becomes minus 4x to the fourth, right? 2x times negative 3x squared.
6x.
Negative 6x to the third, but then it becomes plus 6x to the third because of this minus, okay? 2x times 2, 4x, but then it becomes minus 4x. All over x to the fourth, right? Okay, anything cancel out?
Oh, just kidding.
Those guys cancel out.
Yes, they do. I didn't see that.
And then 6 minus 4 is what? 2x to the fourth minus minus 4x over x to the fourth, okay? Can I do anything to that?
Take out an X.
Take out an x? A 2x? Well, let's just take out an x, because we didn't take out a 2 at the very top one. So then we'll end up with 2x to the third minus 4 over x to the fourth. And now what happens? This x will cancel out, and this will become a 3, right? So do we end up with the same answer? 2x to the third minus 4 over x to the third? So if you check your paper at the top, that is the exact same answer that we got earlier. Which one was a little bit less messy in this situation? The top one, right? So what is the lesson that we're learning here?
It's not
When to
always-
use it and when not to use it, right? If I'm able to put it in polynomial form, I don't want to use quotient rule, I'll just write it in polynomial form and use power rule, okay? If I can't write it in polynomial form, and I'm forced to do it using quotient, then I have to use quotient. Good? Alright, so let's try this next one. What do they want there? Equation of the tangent line. So what are the two things I need for that?
Thought.
I need my point,
And sauce.
and I need my slope. So how do I find the point of tangency? Plug -2 into the original equation before I start doing anything else, so I don't get mixed up with two different equations. So we're finding g of -2, so plug it in. 2 times -2 minus 1 over -2 plus 3. What does that give us? -5 over 1, which is -5. Easy? Okay, equation of the line. Don't forget. Second thing is the slope. In order to find the slope, I need the slope generator, and the slope generator is the what? Derivative. So I need to get the derivative of this function. What do I notice about it? It's a fraction, it's a quotient, right? It's something divided by something else. I cannot put it in polynomial form, because if I send this up, it'll be all of that to the -1 power, and I don't know what that is, right? I can't work with that. So I have to do quotient rule, okay? So let's do it. Ready? So what is it? Low! What is the low part?
X plus 3.
X plus 3. D high! 2. Minus. High. D low. Over. Low squared, which is x plus 3 squared, right? Okay, is this already mathematically my derivative? If I wanted to plug in the -2 for every x at this point, could I? And still find the slope?
Yes.
Yes, but let's practice our algebra, let's practice simplifying it and make it look a little prettier. Okay, so what do we end up with here? Let's go quick. 2x
2x
plus 6
minus
minus 2x plus 1. Be careful, you're distributing that minus, right? All over x plus 3 squared. I don't want to square that one unless I really have to. Okay, so the 2x's will go away. 6 and 1 is what? 7 over x plus 3 squared. So do I have my slope generator, my formula for the slope of any tangent line at any point for this particular curve? Yes. All right. We want one specific slope, and that one is at what? At -2. So let's find g prime at -2. So we got 7 over -2 plus 3 to the second power. What is that going to give us? 7 over 1, which is just 7. So now can I write my equation of the line with the two things I have? All right. What's that equation going to be? Y plus 5 equals 7 times
x
plus 2. Super easy? You getting it?
Yes.
Quotient rule is not difficult. It's probably just the algebra that's going to be difficult for you. Okay? So you need to improve your algebra skills. So we're not only doing quotient rule today, we're also going to go over the derivatives of the other 4 trig functions. What was the derivative of sine? Cosine. What was the derivative of cosine? Negative sine. Do you remember that magical moment that we had where we did all that wonderful work to derive the derivatives of sine and cosine? Remember? It was so much fun.
Oh yes.
Well, now we're gonna relive that experience, and we're gonna figure out the derivatives of the other four trig functions. Tangent, cotangent, secant, and cosecant. Okay? Except that magical experience with these is a lot shorter and a lot easier. Okay? Because of the quotient rule. Okay? And can we write all of these four in terms of sine and cosine?
Yes.
Like what would tangent be in terms of sine and cosine?
Sine over cosine.
What would cotangent be?
Cosine.
Cosine over sine. What would secant be? 1 over cosine. And what would cosine be?
1 over sine.
We just did, cosecant. 1 over sine. Okay? So as long as you can write them in terms of the ones you know, then you can find their derivatives, right? That's what I'm going to show you. Ultimately, when we finish, okay, those four derivatives that you find, you need to memorize them. You need to know them that quickly. But at least you'll be able to find them in case you ever forget them. That's what I'm going to show you how to do. Pretty good?
Yes.
So let's look at tangent, and they want me to get the derivative of it, but I can't because I don't know. But I know what the derivative of sine and cosine are. And I know that tangent is sine over cosine, right? And that's a what? That's a quotient, right? So I need to use the quotient rule if I want its derivative. So here we go, let's do it.